something changes its velocity relative to that fixed Euclidean entity, then something has to make it change its velocity. So gravitation becomes a force in Newtonian because of that fact that things travel on parabolic trajectories, and therefore there has to be a force making them do that.
It's like this whole thing with mass attracting mass. Well, as a that's an observation. And, on the moon has gravitation. Things fall to it and land on it. And the moon's gravitation affects the tides. So the tides are attracted to it. The moon stays in orbit. So there's a net attraction of moon to Earth, Earth to moon. And then you can combine, it's like we see so much mass attracting mass. I don't know where they get off saying that that's cool story, bro.
Somebody explained to me that it was because they thought it was unfair that someone taking the globe position could use the simpler Newtonian position when it suited them, but not defend everything in relativity, which is what obviously you would have to defend now that relativity has come around.
Well, yeah, it's like, oh, black holes, dark energy, oh, gravitation, oh, all this spooky stuff, right? It's like, yeah, but the South Pole, doesn't exist. It's like, wait a minute. It's like the South Pole, the shape of the Earth, and the motion of the Earth needs nothing about astrophysics.
I mean, dark matter or no, it doesn't change the shape of the Earth.
Yeah, well,
and actually, no matter what astrophysics may come up to redefine gravitation, Einsteinian relativity, either refined, removed, replace, it doesn't matter. It's whatever they come up with will still solve for the 9.8 meters per second acceleration on a rotating Earth that's 8,000 miles in diameter and orbits the sun with 186,000 mile diameter, or 186 million diameter. None of that will change no matter what astrophysics comes up with. It must also include the solar system.
Yeah, and the fact that we know for sure now that Newtonian gravity and dynamics are fundamentally wrong, right? They're based on a thing that is not true. They themselves are really good at making the calculations that we need, so good that we'll always use. There's absolutely no possibility that we won't always use Newtonian gravity and dynamics for solar system exploration and building bridges and everything else. It doesn't matter. It doesn't matter that it's fundamentally wrong. What matters is that it gives the right answers.
It's kind of like small angle approximation, right? If you're only dealing with like one or 2 degrees, you can really just deal with very simplistic maths and get the same answer as if you went through the full quadratics. So with Newtonian mechanics, as long as you're staying under the 5% of speed of light, you're not going to find the difference.
What do you guys think of the flat Earth theory?
Not even a theory. It's not even a hypothesis. It's undefendable, undefensible.
That's what I'm saying.
So one thing I was asking the other day, as long as there's a little lull in the conversation, when I talk to Alan, people like him, I never quite, because he's apparently flat Earth, even though I think it seems like he'd be satisfied with geocentrism. The weird thing is he goes through, so he I don't know if he purposely does this, but he'll take all of the 19th century attempts to understand light. He'll take Airy's failure, for instance, and Arago and all these other things. He'll cast them as failures to detect the motion of the Earth, when that was not what they were. We already knew for sure that the Earth revolved around the sun. That's what aberration and parallax had shown. There's really no good way to understand those other than the Earth going around the sun. But then he'll simultaneously use Airy's failure to detect an additional aberration as some failure to detect motion of the Earth, even though it's tacked onto a thing that itself does. I just don't understand how Alan and his ilk explain away aberration and parallax. That's the first thing you have to do. 19th century physicists already knew that the Earth did move, changed its motion in particular. That's the important thing. They were just trying to find that its motion relative to the ether, and failed to find that. So I just don't understand how they deal with parallax and aberration. Anybody have an idea?
Yeah, just like with Michelson-Morley, the motion of the Earth was integral to their measurements and observations. That was if the Earth was not moving, then they would have done a different experiment. I mean, so it's like they pulled out measurement devices incorporating the motion of the Earth, and the ether was not visible. The motion of the Earth was not visible in the alleged ether. It's the ether that went away, and I don't know why they turn that around upside down, and why they'll be going back to, oh, so and so said in 1870. Well, that was pre-electronics. That was just using very simple optical measurements. But if I plot a theodolite, you can't use optical measurements.
Can you refresh me and tell me what measurement instruments they were using?
For what? For
What you
Michelson?
would, yeah,
The Michelson interferometer. Well, in Michelson's case, Michelson Morley used the Michelson interferometer, and Michelson won a Nobel Prize for the interferometer.
I did a whole series of presentations. I'll put the link to the first one, and you can follow them all if you care, on stellar aberration, motivated by Alan's introducing me, or somebody introducing me to Airy's failure. I did a deep dive into that. And it all started really with Bradley looking for stellar parallax, right? Bradley, in the wake of Newton, people were pretty sure that the Earth revolved around the sun. It was such a simple explanation. It seemed to cement the Copernican idea. And so there should be parallax. Should be able to see the stars wagging back and forth once per year, depending on how far away they were. And so Bradley was looking for that, and he saw a signature that looked a lot like parallax, except that it was 90 degrees out of phase with what parallax would look like. And he finally realized that it wasn't parallax he was seeing, it was aberration, the effect of the motion of the Earth on the apparent direction from which the light comes from the star. So when you move toward a star, it kind of moves downward, apparently toward the horizon, just because you're, like when you just draw your pic, like going through the rain, running through the rain, you have to tilt your umbrella forward. The rain looks like it's coming from, closer to the direction that you're moving. That was the explanation that lasted for a long time. And then in the 1800s, parallax was finally seen. Bradley didn't see parallax because it just turned out the stars were much further away than he realized. And it wasn't until the 1800s that we had sensitive enough instruments to detect the parallax. So now we have parallax and aberration doing exactly what you'd expect. Aberration affects all stars in a given region of the sky. Parallax affects only those stars that are close, and you can tell how far away they are from how much parallax and all of that stuff. So those were kind of the initial things. And then there was the question of what's the nature of light? Is it particulate or is it a wave? And Newton thought it was corpuscles. He thought it was particles. That was the prevailing view until the early 1800s, when Fresnel kind of started to move people toward the wave theory. It's really an interesting story of 18th and 19th century attempts to deal with light, understand light, and understand astronomical observations. And I'll put a link in the chat if anybody cares to start my 5-part series.
Yeah, thank you for calling it a story yourself, sir.
Does it stop with once upon a time?
I didn't. That was a question for me. I didn't catch it.
No, I was just thanking you for calling it a story. Thank you.
No, I wasn't talking to you. Somebody asked the question, I thought, after, maybe I misunderstood it too.
Yeah, I'm sorry. Maybe you thought it was a question, but it was not. I was just thanking you.
I think someone said, does it start with once upon a time?
So, what did you guys subscribe to? Newtonian physics, or agree with that?
Sure.
Sigma.
I mean, I don't see most, or a lot of people in these conversations see, this great necessity to say one's right and one's wrong. Newtonian versus Einsteinian gravity.
Yeah.
But either it's a distinction without a difference, or you're talking about like 9 places after the decimal point or something where they would disagree in things that we would perceive in our daily life.
What are the chances that both are wrong, Newtonian and Einstein?
Well, do you count incomplete as wrong?
Like not finished?
Yeah.
I wouldn't count it as wrong, more than just like missing some key details.
So everyone thinks relativity is incomplete.
Yep.
There's not a quantum theory of gravity, which people expect to be a key part of whatever rabbinic understanding we have next.
Yeah.
I think it's conceivable that there may never be a quote quantum theory of gravity, but it's very clear that our understanding of gravity is not complete.
Right. So,
Hmm.
but in terms of being wrong, if you mean like it could suddenly turn out to be electric universe or ether, I don't see any. I don't know that there's any evidence of that.
All right.
According to the current, I guess, popular belief, is that, from what I've been reading, is that it's not compatible. There'll never be quantized gravity. It's just not compatible at that level, at that scale.
Yeah.
But that's not to say that there will never be, but it is the case that right now there seems to be, and and maybe I would even say that there seems to be, seems very strongly to be an incompatibility between the two. I think Susskind would say something different. He wouldn't so much say that they're incompatible, but that we don't quite understand how they both work together or something. But it's certainly true that they are incompatible, like at the center of a black hole, things like that.
Those
The
are the
beginning of
terms.
time.
Yeah, those are the terms they use, like incomplete instead of wrong. They try to get like, make it more palatable, shall we say?
Well, if so, first off, where it matches the observations, which is, very, 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 very many places, you can't say that it's wrong. Where it doesn't, which is in the cosmological realm, which is about the realm we probably know the least about scientifically, that we're still building tools to explore it, to get what information we can. When it doesn't match those, it might be wrong, or there might be something that's exerting gravitic force that we don't detect with our tools. So, you can say that means it's definitely wrong, but I'm not sure, other than wanting to say that, how you would defend that.
Well, the thing is definitely wrong. Now, you can put extra mass there to make it right, but there's no question that it's wrong.
What if there's a mass that we can't detect with our telescopes?
Yeah, of course, you can do the what ifs.
Well, that's what the observation seems to be. It doesn't seem that we're wrong about how gravity works at large scales, because that's not what the data looks like. The data looks like that in some cases, not in all, but in some cases, there is mass that we are not detecting.
Well, I think that, to really put it, I mean, the truth at the fundamental level, the observation is we think we can figure out how much mass a galaxy has from how much light we see, how many stars there must be, how much mass that would represent. And we know for sure that using relativity or Newtonian mechanics, that's not enough mass to make the galaxy rotate as fast as it does out at the extreme, to keep the galaxy together rotating as fast as it is. So something's wrong, right? Is it gravity that's wrong? Or do we have the wrong amount of mass? Is there mass we can't see? There's all sorts of possibilities, but there's a fundamental conflict between how much mass we think is there and how fast that galaxy is rotating.
And,
No,
and
that's
some,
an honest
some
statement.
galaxies are bang on target. Like they look like we would expect for the speed they're rotating. So whatever it is, it's not distributed evenly, and whatever the effect is, it's not distributed evenly. And there's plenty of cases where what we see comports to the theory. So,
Yeah, thank you. You mentioned telescopes. Are there any other probes that they're utilizing at the moment? Satellites?
there's different. Yeah, there are satellite telescopes for sure. Yes.
But these are galaxies, right? I mean, it's going to be a very, very long time before we use anything but telescopes to understand galaxy.
Right.
Webb telescope.
Would you
So they're not
comparing
making any
the
probes?
distant?
Oh, go ahead.
Go on, Eden. It's all you.
Oh, thank you. It was just a question. So I know we use telescopes in space, but are they using any other sort of tools to scan the sky other than optically?
Well, yeah, gamma ray observatories. I mean, we look at all forms of electromagnetic radiation, basically radio waves, visible light,
Gravity waves from LIGO.
and gravity waves. That's right. That's true. That's right. Electromagnetic and gravitational radiation. That's right. But all those things are kind of referred to as telescopes in some sense, right? We're observing radiation from them, where we can't go there and examine them.
We'll call them telescope curious.
But
Telescope
locally,
adjacent.
there you go.
So are all the observations from this made from the ground, or also space-based telescopes?
Both. Like JWST is in space, and there are several, that are in space. I think Gaia is in space.
Over the decades, there's been dozens of spaceborne telescopes in different spectra and in different portions of the sky, trying to glean different things. Trying to look at the CMB, trying to look at the distribution and locate fiducial location of things, as well as their composition of things. Yeah, many spaceborne telescopes. And many Earthborne telescopes, and yeah, they have different limit. The Earthborne ones have different limitations, but then they have, they're looking at different aspects. So yeah, there's lots of observation going on, and yeah, it all involves the sensing of some part of the electromagnetic spectrum and gravitation.
I had the opportunity to visit the Homestead Neutron telescope, and that's a telescope that's at the bottom of an abandoned gold mine.
Yeah, there's several of those neutrino detectors around. That's like the newest thing, like the one down in Antarctica, and then Japan is building a huge one, and there's a couple others, because they're massive. They're massive tanks of ultra pure water and all kinds of exotic detectors, trying to, see where they can come up, find that the transit. Was it hydrogen to radium or radon or something?
I have a question.
I just looked up the Wikipedia page for space telescopes. I stopped counting at 60.
I have a question.
More than 60.
I have a question.
That's a lot.
I have a question.
Okay.
Go.
Can I pose my question?
Yes, please.
Yeah,
Go for it.
apparently, I was watching news. I know I should be ashamed to admit that, but I was watching news, and they said that a telescope in space, I can't remember which one it was. I did know it, but I can't remember now because it's just completely past me. But they found a new planet, so it's most probably the most recent new planet found, and apparently that's from Earth. It's 127 light years away. So I just wanted to ask one of you guys if you knew what telescope it was, and can a telescope really see 140? I think it was 147 or 127 light years away.
So they're not looking at the planet. They're not imaging the planet. What they do is various things. They can look for wobble, physical wobble in the star. They look for Doppler shift showing wobble in the star. They can look for, if the planet passes between us and the star will dim a little bit, and they'll see basically the eclipse, the partial eclipse when the planet passes in front of the star. Several techniques that are used, but 127 light years is a nearby star, so that's what you would expect.
Could you tell me what planet they found or what star that was?
Oh, they've found thousands of planets at this point.
No, it's the most recent one. It was
I don't know.
It was announced. It's the most recent. It's the newest star or planet ever found.
Yeah,
about 2 weeks ago. It was announced on the news. Because NASA's got this funny thing of it's like this news station has a feed for NASA. I know every week they announce something from NASA. It's amazing.
No, and NASA releases they do press releases.
Well, I'm telling you,
press releases. So they say, "Hey, we found this is interesting. Look at this. Take a look at this, guys." And the news report. Sometimes the news will report it. Sometimes they won't really cover it. It's not that big, and sometimes it seems big. Okay, let's show this news report that NASA just put out.
And again,
is this maybe Gliese 12b? I'm just seeing something. I mean, I remember that when they found this, it's an Earth-sized planet orbiting a red dwarf. Most of these planets that they discover are orbiting red dwarfs. Oh, I shouldn't say planets. Most of the planets that they think might actually be habitable are orbiting red dwarfs for reasons.
What red dwarfs?
Well,
red dwarfs are small, cool stars. They're small, cool stars.
Sleazy brought some information about finding a planet. Did you just read the headline, or did you read the whole article?
No, it was on the news. I don't know if you know what the news is like in the UK, but it's a program and it comes on and they say they announce it.
Right.
On the telly.
And then they have a stargazer, someone associated with NASA or a NASA representative, and he's sort of he's at a desk and talking about this star. It's amazing.
Is this the first time you've seen the news? It's novel.
I tell you what news it was.
This guy reads it and he's got a tie.
If you watch GB News, it's on every week.
It's just like this is new.
Oh yeah,
This is a novel concept.
Representative from NASA or
I'm just being funny, man.
space geezer.
This is the planet. It's K2-18b. K2-18b is the one he's talking about. 124 light years away.
Did they use an airplane telescope?
Let's see, what is they?
To exaggerate.
Almost surely.
Telescopes
It
are
is JWST. It was found by JWST.
Yeah,
It's actually pretty close, isn't it?
That's pretty close. I mean, they find them closer than that, but that's a pretty close. They'll only find them around pretty close stars.
How far is 124 light years?
It's that
Just
far.
so I can get
far.
my head. Huh?
Well, so the nearest stars. The nearest stars are about 4.
Can you? So it's got to
The
be.
nearest stars are 4 light years away. So this is 30 times further away than the nearest stars.
And JWST directly imaged a couple planets at 12 light years away.
Oh yeah.
What was the apparatus?
Was it on an airplane?
Webb
Space
telescope.
telescope did they use?
Webb telescope.
If you were going to make some observations, would you rather do it from the ground or from?
They said it
one
was
of
a
the-
telescope.
From space. That's why there's so many. That's why there's so many, because it's much better outside the atmosphere.
Yeah.
And then one of the biggest problems that's coming up is the amount of satellites in orbit. It's
And
now
they
getting to the
said
point,
they
particularly
put
with
like a multi-million-pound space.
particularly with SpaceX sending so many, is you've got light pollution with satellites passing in front of telescope observations. So it's much better to do it from
Webb
space,
is-
even more so now.
Webb
Well,
is
they
nice
said-
because it's at L1, L2. I
yes.
think it's at L2, so it's a million miles from Earth. It doesn't
Yes,
have any trouble with all the
explain
lower
what L.
orbiting.
can
So
you explain what
L2 is a place.
points?
Yeah, that's a place that's on the other side of the Earth from the sun, and it happens to be just because of the gravity of Earth and the sun. It has a little extra gravitational force so that it can orbit the sun once a year, just like the Earth does, which really means that it stays exactly where it is relative to the Earth. It's always a million miles on the other side of the Earth from the sun, and that's nice.
How many Lagrange points are there? There are 3, right?
There's 5.
5. Okay.
We have L2 in England. It's like in Liverpool. It's like Everton.
But you have radio telescopes as well. So in the UK, the one would be Jodrell Bank.
Jodrell Bank,
and then the other one's Goon Hilly. Both of which are I think they're both still working on. They're ancient though. But those are radio telescopes.
Someone told me that even the telescopes from the 1800 were just as good as the ones now. Is that true?
No.
Nope.
Germany's
That's
making
not even close.
They
not even by a
if you do
magnitude.
the experiments in the 1800s, they had just as good. There's not much change. It's just that we can launch one into outer
on an
space.
airplane. Well, I think
That
they're
is-
on-
We have
Orders of
bigger
magnitude.
and sharper telescopes by far than we did in the 1800s.
Do you think they'd be pretty scared to like put a telescope in space, thinking it might get hit by a rock or something?
I mean, if you were to fly up to about 150 miles up and drop a rock, and then you have your friend in a boat in the Indian Ocean, and you fly over the Indian Ocean, drop a rock, what are the odds of you hitting your friend? Now multiply that by about 1,000, and that's what you get. How the odds of being hit by something in orbit?
Yeah, but they say there was a little while ago, a couple of weeks ago, there was a meteor shower. What's that all about?
Oh God. And to be clear, JWST did get hit by a very small, tiny little pebble-sized rock. It hit one of its mirrors within like the first month of deployment.
So right, let's do the maths on that. So what's this telescope traveling at, or is it geodetic, or is it stationary?
Stationary with respect to
Real quick, Invincible, you're leaking your hot mic a little bit, Invincible.
So what do you
My
think
bad.
the pebble was traveling? It's got to be more than 17,500 miles an hour.
Doesn't have to be.
Well, it travels about 30,000 miles per hour around
So
the
you
sun.
imagine the impact that little.
doesn't-
You could shoot a pea.
Some
Imagine
things
the
are-
impact of 30,000
Yeah,
miles
exactly.
an hour.
Yes, that's true. But some things are not moving that quickly in relation to the other things. They are moving quickly, but think about it. Think about it.
Well, they are.
If you have a throw a stone at someone and they're running away from you, the stone might hit your friend, right? You throw a stone at him while he's running away.
He's not running away at 30,000 miles an hour, though.
It will hit his back, but it won't be very, it won't hurt him very much. But if he's running towards you, it will hurt him a lot more when you throw the stone at him, right? So if you've got two things and they're both moving in a similar sort of direction, they're not going to be relative to each other. They're not going to be, the impact isn't going to be as great because they're not moving the disparate speeds aren't going to be as great.
Well, we need to find out. We need to get the numbers on this and do the calculation to see
Well,
what's the impact of that hitting it.
Very simple. Very simple. Does the Webb telescope still operate? If that's true, if that is so, then it wasn't it wasn't moving very quickly in relation to the
Well,
telescope.
it might just be a little bit of a made-up story. They might have just been getting a drama.
For what purpose?
No, it's just drama. Well, we haven't heard nothing from the
drama.
web station. Let's make something up. It's like
Drama.
EastEnders.
It's very hard.
You're saying for drama, but you've never heard of it.
It's very difficult.
Just now. What drama did they announce it on the news? Did you hear about it on the news? Then what drama are they trying to create if they didn't announce it on the news and everyone knows about it?
It's a
Yeah,
whole-
because
Think these things through, man. Come on.
no,
Drama.
it's just come on. I don't think you can. You can't detect something 124 light years away. That's just insane.
It's insane. What is the limit then? Just give us a number. What the limit is?
I don't
1,000 miles, 10,000 miles.
know.
At what point does it become
When I hear
impossible?
stories, it's pretty like when I'm listening to your stories, I'm thinking like, my God, you know.
Yes, these
I
things are
don't-
really
I
happening.
don't know. You just believe everything you get fed.
Well, compared to this, it was just disbelieving everything you.
No, I don't disbelieve
said because the
everything
numbers are
because
low.
I want to be in it. So like, I sometimes
Right.
try to understand that, like there's always something. regardless of what, there's always
Yes.
something which, you know,
exploration
you say,
and
like, we're
observations are
losing, we're
always
not
going on.
losing, with your own experience, but you should do. Yeah, it's like
Most of
there's
the
always
time,
something what makes me
But
think.
most of the time, people aren't paying attention to it. On the odd occasion that something, oh, this is interesting, NASA puts out a press release. They put out a lot of press releases. But if they put out a press release saying, oh, we landed this thing and it didn't smash into 1,000 pieces, that's not that newsworthy, some
What,
rock or something like that.
money?
And sometimes it is, like when they collected samples for Japanese, no, it wasn't, it was the Hayabusa, what was it called? They collected the sample and brought it back to Earth. That's newsworthy, that's a big deal. So sometimes they do that. But there's always stuff going on, because there's a lot of space agencies. So yes, but to say it's all a story and they want drama.
I sense he's going to put a telescope up soon, isn't it?
Well, I don't understand. I'm trying to figure out what would be the reason to just make up stories like that. Just
Because they're taking fucking lots of money off people.
You already have your money.
Huh?
The government already you realise that the government already controls all your money, right?
Yeah, but
already have all your money.
It don't. Right, your government taxes you to death. Yeah. Then they give these agencies money, and these agencies, they don't get money for nothing. You have to give me something. So it's like quid pro quo. I'm going to give you something, and you're going to give me something back. Otherwise, you don't get no more somethings if I don't get that something back. You know, if you can't.
That's called discovery. That's called human inquisitiveness and ingenuity and discovery. What we're getting back is information that helps us understand things.
All they do is give like these fantasy figures in you know, like 127. They might as well said, do you know what? We've seen a planet. I don't know where the fuck it is. It's fucking doing something. We don't know what it's doing, but it's there. They might as well said that with the numbers they've given you. Is basically what they've said.
Have you ever used Velcro?
Have I used Velcro?
Or GPS? GPS is a good one.
Not it.
What about the anti-reflective coating on eyeglasses? You ever known somebody who used that?
No, I don't use eyeglasses, so I wouldn't have a Danny.
Have you ever ate French fries?
All of these things are directly developed by NASA. Just so
hold on. Have you went to McDonald's and ordered a Big Mac and fries?
Sometimes it hurts.
Yeah.
Be honest.
So that was kind of a late. Come on, that was out of the field question there. Come on.
Sometimes.
Oh, look, I get back on.
There was a claim that they don't give anything back. So I was showing everyday products that were developed at NASA.
What? No, give me one.
The point of here's the thing. The point of exploration like that is we don't know what we're going to find. There could be a situation where we could find that, for example, creating certain medicines in zero G or creating certain medicines in certain compounds is only possible in zero G. So with enough research and enough time, we could find out that is the case. In fact, I think that is the case right now, where certain things can only be produced in zero G.
I've got one for you. NASA.
Did you hear what I just said?
Yeah, I did.
Okay, all right. You acknowledge what I just said, that there is things that are useful. It's not just, we found this part in the sky.
I do remember NASA.
Okay.
I do remember NASA putting in one of their little pamphlets about they had this magical, like it was a potion which cured everything, and especially like, if you've been to space and you had like space sickness, it washed it all away. And I looked at it.
This is just magical.
No.
It's just
to listen to what it was. It was actually chlorine dioxide, and they were trying to, like put it in a way that it was this special. And I swear to God, I kid you not, if you're like one of these NASA freaks, you could go out and find this. And if you read everything into it, it's clearly chlorine dioxide. So,
all right.
Talking about medicine.
But that's
I'm pretty sure if you drank bleach, you'd know it, that you drank bleach.
Yeah. But what I'm saying is that the act of exploration.
It's not bleach.
No, chlorine dioxide is bleach.
Huh?
Chlorine dioxide is bleach.
No, it isn't. That's where you're absolutely wrong.
Google the
I don't need to Google anything. Bleach. I know it's 100% you're wrong.
Okay, do you want a link?
No, I don't want a link. I think you are mistaken. I know about chlorine dioxide, so you can't tell me. Oh,
are you talking about chlorine?
It's bleach.
Yeah, chlorine. Chlorine dioxide.
Chlorine dioxide. It hasn't even got the chemical, listing for it to be a bleach.
You can check that. You can Google the compound and see that it's used as a bleach.
You Google it. If you want to Google
I just
something,
did.
you Google it.
Yeah, I just did.
It's magic.
So what?
It is commonly
now-
used as a bleach.
Oh, you're mad. I tell you where it's used in
I'm-
hospitals. It's used in hospitals.
Okay, I'm gonna post a link. Get ready to read.
I don't care about your link. Hospitals, every hospital in the UK uses it. I would imagine in America as well. If someone cuts themselves in a hospital, they'll get a little bottle of chlorine dioxide and spray it on their finger. Why would they spray bleach on their finger? You can Google that one.
Are you talking about hydrogen peroxide?
No.
Yeah, maybe that one.
No,
Hold on. I've worked in a lot of
Hydrogen
hospitals.
What the fuck are you talking about, guy?
This is what you fucking. What the fuck are you talking about? I'm being serious. It's used in hospitals.
Are you?
So don't say it.
Like
And
hydrogen peroxide. Okay.
kills everything.
Right. Do you
Not
think
chlorine
that
dioxide.
people are spraying? Do you think people are spraying open wounds with bleach? You're fucking insane.
You don't know fuck all.
Man,
I swear to
look
God, if
in
you
the
cut yourself in a
omnipresence
hospital,
text chat.
they will spray chlorine dioxide on the cut, 100%. And if you think I'm lying,
Yeah, for a cut, you would use hydrogen peroxide.
what do you want me to do?
I
Do you
worked
want
in
me
half
to?
a dozen hospitals.
I get you a testimony from a nurse who
I
works in
don't give a
hospital
fuck
to
about
tell
the
you that.
testimony. I give, like, I actually
But
care
you want
what's
to
written
Google
about
it?
the
I'll give
chemical.
you the testimony from a nurse who will tell you that.
Okay, hearsay, great. Too bad I
Hearsay.
have science.
What do you want me to do? I make a recording now. I can
They
I
don't
was a
even need to
paramedic.
if you want. It's not
Oh,
a
look,
lie.
yeah, look, we have a
It's not a lie.
paramedic here. Now listen to him instead of a nurse.
No.
Right. I was a paramedic. I worked at multiple hospitals, both
Oh
civilian and
yeah, I bet
military.
you were.
Yeah, I bet your
Yeah.
nurse was a nurse. Like, what the fuck is that
Yeah.
argument?
Yeah.
What even is that argument?
Okay.
Do they use water?
No.
Or do
You
they
went to the
use,
moon as well. I remember.
No.
I saw you on the moon. I see you. I see you wobbling on the moon.
You
I
okay?
googled it. That's how I know.
I don't know. You
I
might
googled
not
it.
be.
googled
You
it.
might not be okay.
I googled it. That's how I know.
Hey,
it was
Schlitsky,
on the moon.
don't ever change. Please don't ever change.
I've never. Do you know what? Because I know
No.
about chlorine dioxide. It's a bleach.
Yeah, you didn't know that it's used as a bleach, so you clearly do
You're
not know.
absolutely mental.
So the
Read
rockets.
read what the chemical is used as.
Use
Use your
ass.
goggly eyes and read what the chemical is used for.
Why are you bringing ass into it? If you want some ass, you have to go on to
Ice.
application or something. Not maybe this Discord.
Man,
That's mental.
ice.
You said
You
ass.
read with your
I want
ass
some
or
ass.
eyes.
You said I want
glorious.
some ass.
I'm crying here. This is-
Well, anyway, let's forget about it. So you went on. You
This
went on to
isn't, if this
Google.
is an act,
Went on
I
to Google.
I
Of all
applaud you, sir.
places, the plethora of truth. Google. I went on to Google. I saw it on Google. It's 100% real.
It's got to be a performance,
Yeah,
right?
sorry, let me walk up
This-
to my
this is
library and
performative.
ask them if they know what chlorine
Performative it
dioxide
is.
is. Give me like 5 hours or so and I can get back with the answer instead of using Google.
It does feel
Is that
performative.
better?
And crazy people get crazy ideas. Google. Before you go out the front door? Do you go on Google just to find out what's going to
Yes.
happen?
I go on Google and check the weather so I know whether or
Yeah.
not I'm going to get wet.
Yep, check the maps. I do that.
Yeah.
I'm
check
Apple.
the weather. It's
Apple,
never
Maps.
correct.
What's the traffic like right now?
Yeah, it's
Yeah.
like in your face, most probably.
I'll say 2 hours.
What's the